As also, sadly, the video from last time was lost. Like it was uploading here. It was only 75%. Like, oh, should be. I walked off. Assumed it was good. It's supposed to load into the cloud. Yeah. Never showed up in the cloud. It's gone where it went. But I did send you the written notes. So like this time I'm going to sit here until that thing loads into the cloud. Usually I save, well, when I'm at home, I save directly to the laptop, so I know it's good. But over here, I can't save it to the computer. So I got to be careful. All right, so far we've gone over, we did sequences, and then we talked about a sequence only converges if it has a limit, and it's finite. Then we went on to series, which is a summation of terms of a sequence, basically. It's okay. If you need to do it, no worries. Okay, so we started series, and then we did geometric series. We defined the idea in general what it means for a series to converge. That means the sequence of partial sums or the series of partial sums converges, therefore the series does. The geometric, and then we did the integral test, and then we talked about the p-series. That's what we did last time. So now I'm going to add another test. So that's like what? Geometric, p-series, integral, nth term. So that's kind of about 4 tests so far. So this is about the 5th one or so. Oh yeah, thanks. 1 second. Direct comparison test. But 0 would be less than a sub n, which is less than or equal to b sub n for all n. Okay. So basically I'm saying that the sequence of an is smaller than the sequence of b. Okay. So if that is true, then the following is true. If the series as n goes to 1 to infinity converges, then n equals 1 to infinity. The a sub n also converges. Okay. So I'm going to try to draw you a picture here so you can visualize what I'm talking about. So I'm telling you that, oh, okay. Forgot to write bn. I said it, but I didn't write it. If the series of b sub n converges, then the series of an converges as well. So let's pretend that this right here is a sequence converging to some number. This is, we'll call this one bn. So if bn is bigger than an, then that means an has to converge somewhere, right? You see how bn is trapping it underneath? That's what this is telling you here. If an is less than bn and bn converges, then an has to converge. This is how I visualize it in my head. It helps me understand what number one is saying. Okay, that makes sense. That's why it has to be, this one has to be less than this. So the convergent one has to be bigger. Okay. Number two. If the series n equals 1 to infinity of an diverges, then the series of n equal 1 to infinity b sub n diverges. So this is the opposite. So if you know that the small one is going to diverge, right? Bn or an, that means that Bn has to also diverge, right? Automatically. Like let's say it's going, we don't know what it's doing, it's going like somewhere over here, we don't know. But we know this one is going to shoot up, but this is the small one. So of course, Bn would diverge as well. Is that logic? Does that idea make sense? Whenever I'm doing direct comparison, I always try to remind myself, which one's the big one? Does it converge? Does it diverge? Okay, depending on what's happening, I can use these ideas here. Although, let's say Bn diverges. Right. Shit, I put that backwards. I had it right earlier, but no. The small one is An, and we know it is divergent. We don't know what Bn is doing, but because this one's smaller, then Bn diverges. That's what 2 is saying. Okay. The trick is to figure out what to compare it to. That's the hard part. Once you understand this, the hard part is picking Bn. So, first example. Determine the convergence or divergence of this series. One over 2 plus 3 to the n. So my a sub n is that sequence there that we're summing, a part of the series. Bn must be chosen by us. So Bn use something similar to An. I can choose this guy because I know what this is doing. This is just adding 2 more. So this is very similar. Right? And you agree that this one is smaller. Right? So if I choose this to be Bn, that means that An is less than Bn. Right? Is that clear? We can show it. Right. We know that 3n plus 2 is bigger than 3n. So if I take the reciprocal of both sides, the inequality flips, and this is now smaller. Right? So that's proving that they are less than. So what kind of series would this be? I should put right. Let's look at the series of 1/3 to the n. What kind of series is this? If I expand it, is it more obvious? Right? Is it what test would you want to use when you see this? We have the integral test, the nth term test, geometric test, p-test, and now we have, well, we're using direct right now, but in order to use direct, remember, we have to know what one of them is doing, right, to compare it. So if this, then this, so I need one of them. I need to figure out the hell bn is doing before I apply the comparison. It looks like it, but no. It's the geometric. Right, you see how this is a geometric type, right? Because you have a third squared, a third cubed. So remember how we have to look at the R? The rule for a geometric set, if R is less than 1, then it's a convergent series. So the series 1/3 to the n is a convergent geometric series because the absolute value of R is equal to 1/3, which is less than 1. That's the requirement for a converging geometric. So now we can say, since the series B sub n is bigger than the series. Let me phrase it. Is that how I phrase it? Let's phrase it. Since A sub n is less than B sub n. And series of B sub n converges, then the series of A sub n also converges. Does that idea make sense to you? remember, I'll put that back. He said if the bigger one converges, then the smaller one converges. So I had to choose a BN and show that it is bigger, and then determine that it converges in order to make this statement. That since this is less than that, and this converges, then this also converges. That's the logic. Okay. So I'm applying, this is by, yes, the direct comparison. That's what I used to verify that the other series converges. Well, I told you last time, right? We don't know what the sum is, but I know I converge. You can ask Euler what the sum is. Any questions on this? This makes sense, or any question on the other page? All right. All right, let's do another one, another comparison. Use a direct comparison to determine if the series converges / diverges. So if we do what we did last time, if the sequence AN is this, what do you think the B sub n should be? So we want it to be similar, and we want it to be obvious that which one's bigger. That's how you choose it.
7/8. 7.
Yeah. So yeah, 7 to the n over 8 to the n. Yeah, that'll work. It scared me. Okay. All right, so we can tell, right, which one's bigger? Which is the small one? Okay, both 7n. This has a +6 at the bottom. So if the bottom is bigger, that means that it's a smaller term, right? So that means that AN is less than BN. So we want to, if BN converges, then that means this converges by rule 2, I think it was. Yeah, rule 1 for direct comparison. So we want to show that this series will converge. So we start by looking at it. and determining what kind of series this is. So this is a geometric again. And you can rewrite this as a series of 7/8 to the n. So the r is equal to 7/8. That's the factor they have in common. So now we can make our conclusion, right? So since r, absolute value of r is equal to 7/8, which is less than 1, then the series, I'm going to write it in general, Bn converges to save us some time. Space. Now, since the series, well, since a sub n is less than b sub n, and the series of b sub n converges, then the series of a sub n also converges by the direct comparison test. Any questions on number 2?
Why, what you said, we determined about a to the n plus 6 is more than the one in the top.
By the way, this now before you get to your question, this is by geometric tests. Oh man, can't fit it in there. Right, so I knew this converged by the geometric test. Then I used that statement to show that the other one converges by the direct comparison test. What was your question?
When you said a to the n, the 7n is more than the n. Like that.
Why? No, let's use numbers to make it more obvious, right? So if I have a 3 and a 4, you agree that this is the smaller one, right? So that's all we're saying. This has 6 more, right? So this has 1 more. So it should be smaller. So if we build it little by little, we know that 7 and we know this is bigger than this, right? If I take the reciprocal, you agree that this is less than this, right? Because if I say 2 is less than 3, the reciprocal is that this is not true, right? Now, if I multiply both sides by 7 to the n, nothing changes because I did the same thing to both of them. So it's still less than. So we can show step by step and prove why they're less than. But I did just tell you it is because this is the bottom is, remember the denominator is bigger. That means that the fraction is small. The number is small. So the bigger the bottom is, right? That's all it is. But this would be how you would prove it, I guess. Why it's. And any other questions?
Are we going to? Are we going to do a limit compression test?
Yes.
Yeah, in a minute, okay.
Oh, I think. Here it is. Yeah, let's go over the rules for limit comparison. Give me 1 second, I need to check what we're on the schedule. I'm always paranoid. Okay, so we are on this week. We're doing comparison. Yeah, it should be fine. Okay. Any other question on this? Okay. Well, let me give you the rules for the next test. Limit comparison test is a lot easier to understand. You just take a limit and see what the number is. Although you do have to choose your own. B sub n. That's still true. So if a sub n is greater than 0 and b sub n is greater than 0, and the limit of an over bn as n goes to infinity is equal to L, where L is finite and positive, then that means the series AN and the series BN either both converge or diverge. So if you know what one of them does, so you pick a BN, and you want to pick one that you know what it's doing, or you can figure it out right away. You just divide them, see what the limit is, and then you'll know what the other one's doing, if it is finite. If it is not finite, then you either pick the wrong BN or this test doesn't work. You gotta do a different test. Okay. But right now we're just learning the tests. Determine the convergence or divergence of the series n to the 2n over 4n cubed plus 1. So a sub n is equal to n to the 2n over 4n cubed plus 1. So that's the sequence part. What do you guys think a good BN would be?
Is it 2n over 4n to the third n cubed?
Yeah, that's pretty close. basically we use everything except that one signal. The one is not doing anything really, right? So kind of how we did the last one. You can say, you know what? Let's use this guy here, but this will reduce, right? Into 4n squared, right? So this will be the one we use. So we're going to divide an over bn.
Why does that went down from n cubed to n squared?
Oh, this n will cancel it.
I see.
The n over n cubed.
Yeah.
All right, so now we do the limit of those two sequences. So the limit of an over bn, as n goes to infinity, is equal to the limit as n goes to infinity of this guy. Weird mess here. Divided by this one. Which is the same as the limit as n goes to infinity as this first thing times this other one. So notice that we're going to cancel the two n's, right? And we have n times n there. So we'll get the limit as n goes to infinity of 4n cubed over 4n cubed plus 1. Now this limit is obvious, right? What is the limit? Do you remember? The degrees are the same. Right? You just divide the coefficient of the highest powers if the degrees are the same. So the limit would just be 4 over 4, which is 1. Or you can divide each one by n cubed and end up with 1 anyway. But since we're no longer in Cal 1, I think we can skip that. Take these 4s. Now the limit is finite and positive. Right?
So we can cancel the point.
Not officially, but when we're dealing with infinity, that's pretty much what happens. They cancel out because when they're going to infinity, the plus 1 doesn't matter. So they overpower each other, and you're left with 4. So now we know that either both of them converge or diverge because the limit is finite and equal to 1. Okay, so we need to know what the hell Bn is doing. Does this converge or diverge? If we know what this is doing, then we know what this other one is doing, right? That's what this limit comparison does. Remember I told you the first test you should always use is the nth term test, also called the divergent test. So what you do is you take the limit of the sequence, and if it is not 0, then that means the series diverges. This will be infinite. Therefore, the series 2 to the n over 4n squared, because n goes to infinity. Sorry. N equals 1 to infinity. Divergence by the nth term test. So since the limit, now it's time for the conclusion of this whole thing. The limit as n goes to infinity of an over bn is equal to 1, then Ln and the series B sub n diverges, then that means that the series of A sub n also diverges by the limit comparison test. That makes sense? The limit comparison only tells you what they're both doing. It doesn't tell you what the original is doing. So you have to figure out what your Bn is doing that you chose to make figure out what the other one is doing. Any questions about this? Does it make sense? Okay. Let's do another limit comparison. Let's see, maybe. No, we should be fine. Don't forget. I told you guys the dots mean it's therefore. I don't remember what concept told us. If you read math books, we usually have the symbols. If you see like a little box at the end shaded in, that means that it's done. There's a conclusion. If you ever read math books for fun. Check one out at the library. Yeah. Be careful if it says introductory, it's a lie. That means it's super hard, like elementary or something like that. I don't know why they do that. Abstract algebra, like intro or elementary or something. That book is super hard. Last question here. I think I'll let it big as I'm starting. Especially since I hit you pretty hard last time, 3 sections. Kind of better, but. You guys got the math nightmares yet? I call them problem solving nightmares nowadays. When you're, I'm sure you guys have maybe experienced it already when and you keep waking up and you're trying to solve this problem or figure this thing out. It just keeps waking you up. Then you fall asleep and you wake up. You don't know what the problem is by the time you get up. It just happens all the time.
I haven't had it where it wakes me up, but I've been to answer this breath. Going like, yeah. Not stress. Yeah.
It's happened a lot. In grad school when I was doing that.
If you use all of them. 3 weeks of month ends this semester, it starts to kind of feel like I know I'm boy.
It's horrible. At least we know it's not just us. Yeah, it's probably related to stress and trying to solve something.
Hey, Professor.
Yep.
Have you heard from Tyler?
I don't know why. I know he is having that medical stuff going on.
Oh, okay.
I think I don't know if he'll be coming to class or not, but we'll see. I'm sure I'm going to email him soon about the next exam or whatnot. We shall see.
Yeah.
Last I heard, he was still struggling, I guess. Okay, so AN is going to be this guy, right? It's the original. So what do you guys think BN should be? Yeah, let's try that.
N over N squared.
Yeah, what does that reduce to?
N? No.
Does this help?
Yeah. There you go.
What does it reduce to? That's 2 minus a half. Yeah, 3 halves. Okay. What type of series would this be? It's not geometric. Yeah, this is the P series. And the P is 3 halves, right? Yeah, this converges as a series. So if the limit is finite, when I take the ratio, then that would mean this also converges. So let's go ahead and do that. The limit of an over bn is equal to the limit as n approaches 0. First one, I'm going to write it as a division. That way it's easier to see what's happening. Writing as a complex fraction is not pretty. Right, multiply reciprocal. So that will become the limit as n approaches, well, I put 0 to be infinity. N to the 1/2 times n to the 3/2 would be n squared, right? And that limit will be 1. And 1 is positive and finite. So since the series of b sub n is a convergent P series, because I guess I'll show the, because P is equal to 3/2, which is greater than 1. This is my justification for that. And the limit of an over bn as n goes to infinity is equal to 1, then both series converge by the limit comparison test. I might have a video from last semester. Sorry, thinking about last class. Any questions on number 4 here? All right, that's it for 9.4. Direct comparison makes sense, and the limit comparison makes sense. The next section is, I'll probably wait till next time, but it's going to be about alternating series and the alternating series theorem. Then we'll move on to 2 more tests. So, and this next time will be 3 more tests. And then we'll move on to power series. Taylor series. Taylor is pretty cool though, because it He can give you, can take a function, any kind of function, and expand it and represent it by series, which is very useful in computers, right? If you want, let's say you have a continuous function and you want to program it, well, if you convert f of x into a series that you can just add up or create a loop for, then Taylor becomes very useful. Anyway, we'll see that soon. We'll stop here, guys.
All right.
See you Monday, mostly.
Yes, sir. We'll see you. Bye-bye.